Everyone, welcome back to SAT Math Question of the Day. Here's our question. This is from an educator site from the College Board. This question may be on a Blue Book test, so take that into consideration when doing this. It's spoiler alert. According to the data provided by the U.S. Department of Energy, the average price of regular gasoline in the United States from September 1st, 2014 to December 1st, 2014 is modeled by the function f, defined below, where f of x is the average price of gasoline per gallon X months after September 1st. So its F is 2.7 minus 0.19 X minus 3. The constant 2.74 in this function estimates which of the following. F of 3. Very smart. Why? Wait, let's count. Months, X months. So October is month 1. November's month 2. December is month 3. So it would be the December's price. Yeah, right. Yeah, so it'd be D. That was very observant, Seth, for you to immediately write F of 3. Oops, annotate. That was very observant, Seth, to notice that you should write F of 3. Because you can notice the pattern. Talk about patterns. We always talk, at the end, we always talk about patterns to the problem. Oh, this is so pattern, right? If you don't see the X minus 3 as a pattern, then this problem becomes a lot more difficult. And this problem, by the way, is marked by the College Board as difficult. Yeah. Wow. So this is classic College Board. You got to find the pattern. So if you read this problem and you really don't know what to do, okay, if you're reading a College Board problem, an SAT problem, and you don't know what to do, stop and say, there's got to be a pattern here because the problem can't be that hard or long. Look for that pattern. I didn't have a chance to see it because Seth swooped in and showed it to us. What do you think, Seth? Do you agree that if you see the pattern, you're home free, and if you don't see the pattern, it becomes a really difficult problem?
Well, the two elements of the pattern. That the pattern is they're asking for what this constant estimates, and the constant is right there that way. It's not really the constant term in the expansion of linear, because minus 1900ths times minus 3 is a constant.
You're right.
But it is it's a number. So.
It's a number, yeah. It's a number.
And then so I think it's helpful to glance. I think it helped me to briefly skim the choices, see what they were getting at. What are they asking you? What are the possible properties they're asking you about that belongs to 2 and 7400ths? So it's like price, differences of prices, average, something about a price.
Yeah.
And then I saw, okay, so it has to be. And then, the other pattern that I know, which you didn't mention, is that this function interpolates. It interpolates between the price at 2 values of x. The first value of x is when x equals when x equals
0.
so here when x equals 0, we have the price obtained by subtracting the 1900s 3 times, which is the price at the beginning. It's the price at September 1st.
Yeah.
Okay, so it's price. Oh, sorry. Interpolating. It's interpolating between x equals 0.
Yep.
Which is the number of months after September 1st, and the price.
Well, it's
on September 1st. It's interpolating that between that and x equals 3, and the price on December 1st.
So this is actually 3.31.
Yeah.
It starts out at $3.31 a gallon and goes down to $274.
Yeah, but they didn't tell you that.
Right.
But so I thought of this, and I didn't think of evaluating this number you did. But this is the pattern of a function that interpolates when x equals 3. The function is equal to the constant in red. And when x equals 0, it's the value obtained by subtracting. Actually going back when x go back.
Yeah.
3
go
months.
Back. Yeah.
We add.
Right. Yeah.
Right?
Yeah. So you really have to understand what's going on here. This is, of course, a very convoluted question, which jump to one of the questions you would see in school. You wouldn't see in school because this is so convoluted, and this is so classic SAT. You would normally see this as a normal y equals mx plus b equation, which would be, it's 3.31. 3.31 minus 0.19x, or 0.9 minus 0.19x plus 3.31. This is what you would normally see. But they give it to you in some convoluted way, and then they're asking, what is f of 3? No, not asking what is f of 3. They're asking, what does this number mean in this convoluted equation? So you have to back solve and reverse engineer this thing, or be clever, or notice what we did here, where you notice that when does f equal 2.73 is when x equals 3, and that's the pattern, and then you count backwards. And please, everybody, count on your fingers. Remember, September is 0, October is 1, November is 2, December is 3. But there are different ways to do it. I'm really interested to see how they do it. So thank God they didn't say the average price on December 31st versus the average price on 12/31. I guess that's too complicated for me to even think about right now. But if there was a choice between on December 1st or December 31st, which one is right? Or we can't really tell.
Well, I think I thought of it is the interval that they're discussing begins September 1st. So it consists of all of September.
Oh, I see. The domain.
So I figured 3 because all of September, all of October, and all of November is the interval. And that interval ends right at the beginning of December. So I didn't count on my fingers. I counted September, October, November.
Right, but notice that there are 3 intervals but 4 values for x. Always get that confused. There's interval 1, 2, and 3, but there are 4 values that bookend that interval. That's the same reason why what year, let's say you're say you just celebrated your 15th birthday. As soon as you pass that moment that you were born, you're in your 16th year of life, even though you've passed your 15th birthday. So it's interesting, right? There are 4 boundaries, but 3 intervals. So that's why I personally, when I have problems like that, I count on my fingers. But you're right, the domain, the x values are only to December 1st, right? This equation is only valid to December 1st. So if we know nothing about December 31st. So that's another way to knock out December 31st. That could have been. I wonder if they debated putting that in as a choice. But they didn't. I wonder if they did. We don't know. We'll never know. So before we look at the answer, I know there are other ways to do this, but this is a really nice way, but it takes advantage of the pattern. Well, that's right. I forgot the order already. When we do our questions, we do them before we look at the answer, right? Forgot, do we? Or do we look at the answer first and then do our questions?
Well, we do our questions.
I think we do our questions first, don't we?
Yeah,
we do, so that we have the thing in front of us. Okay, first of all, the most important thing, pattern. We haven't seen a question with a pattern in a while, but boy, this is pattern. You see the pattern, you get it right. You don't see the pattern, you are not going to be doing it. You may not do it efficiently. Starting with guesses, yeah, maybe. I guess you could sort of get an idea as to what's going on here. It's certainly not this one. It looks like this, right? Just looking superficially, this looks possible. No, because it's an average difference and you see the negative signs. So you may say, okay, maybe there's a difference going on. This one really not, because you can calculate it. The average price on September 1st is when X is 0. And you just plug 0 in and you realize that that's not right. So this one you could throw out. And then you could wonder about this. Wonder. And then, this is not a bad way to do it. You wonder. You wonder if this is correct. And it's easily checkable. So that's good. This one is actually easily checkable. So maybe that's what you do. Easily checkable. You count on your fingers what X is December. As we did, it's 3. You check it out and say, wow, look at that. I got it right. So that's another way to do it. Anyway, looking at the answers is certainly a reasonable way to do this problem. We'd already talked about patterns. Different from a school test. Yeah, a school test, they would never give you a convoluted question like that. The teachers wouldn't even know what to do with it. Sorry, but not an insult to the teachers, but...
Well, this is the resource that's made for teachers. So some teachers might.
Yeah, some teachers might. Right. Okay. Sorry. I'm not being nasty.
If I were a teacher, I would.
It's a really hard question, and meaning that a mean teacher. Okay, a mean teacher would do this, right?
A good teacher.
Okay, a good teacher.
Good mean teacher.
Good mean teacher would take this question, right? Yeah. Okay. Please, if any teachers are watching this, please, I don't mean any ill words about that. And of course, the most important question, although in this question, really the key is the pattern. What are the SAT people trying to see if you know what to do, or if you understand? Other than looking at patterns and questions, what do you think?
Basic algebra. Know what the meaning of the operations in algebra are.
Right.
It would lead you to this, to that and connecting the explanation of a function, because it says that the function f of x, knowing what a function is, and how functions are specified by formulas.
Yep.
But also functions associate values for the variable to numbers, and that the notation of the function f of 3, f of x, and all that stuff.
Yeah.
And then recognizing the recognizing from the algebra, no, without having to see any pattern, the from the algebra and the meaning of algebra, that 2.74 pops out as the value of the function, when x equals 3.
Right. Yes.
And that is obvious when you read the algebra that specifies the function.
Aha.
So 2.74 pops out.
Right. So
it's in red. It's in red.
Right. So
when the thing you subtract is 0, and the thing you subtract is 0 when x equals 3. So what's the significance of 2.74 is the value of f of x when x equals 3.
Right.
Well, what is the meaning of f of x? F of x is the price x months after the starting point, which is September.
Yeah.
And x months, 3 months after September, is December.
Right.
So that leaves you right away without any of this other.
Well,
just understand, just recognizing. The first applying the basic meanings of things in algebra when things become 0.
Yep.
The fact that if you have 2.74 plus or minus anything, this equals 2.74 when this anything junk equals 0.
Right. Yeah. So really, it's recognizing patterns in linear functions. Yeah, recognizing patterns in linear functions, analyzing the different relationships that are in a linear function is really what this thing really comes down to. Okay, well, think about that. Normally that skill isn't all that taught in school. In school, you just straight arrow. You have the linear equation, you solve it, or you find the linear equation or something. You don't really analyze what's really going on inside the linear equation to us.
Well, that is what in school they teach that, not in math courses, but in science courses, particularly physics.
Yeah.
In physics, they relate the mathematical operations in the formula to effects that are in the subject of physics.
Yeah. Well, physics is mostly word problems with a lot of math. And all that, because you have to understand what the physics is. Of course, you have to understand what the physical situation is. Okay, so let's look at their answer. I'm really interested to see how they deal with this.
People who you get an advantage on the SAT when you take physics.
Yes. So we would agree, Seth, that this problem we agree with the College Board too, that they categorize this as a difficult problem. I think so. Okay, so let's just see what they do and how they deal with it. Okay, they get the same answer we get, and it's a very short answer. Since 2.7 was a constant term, it represents the actual price of gas rather than a measure of change in gas price. Oh, really? Some of those prices were... Wait, what? Price per gallon. Okay, anyway. Okay, to determine what gas price it represents. Oh my God. Okay, find x such that f of x is 2.74. Wait, how did you know to do that? How did they know to do that unless they knew how to do it? Which is circular reasoning. Subtracting 2.74 from both sides solves it for 3. Wait, but that... Okay, therefore their average... What? It's How would you know to do that? How would you know what's the justification for jumping in and solving the equation f of x is 2.74? What would be the justification for doing this out of the blue? Unless you knew that that would give you the answer.
Well, the justification,
what justifies you to start this way? What justifies you to come up with this brilliant idea? Why don't I solve this equation?
Like this explanation.
Why don't I just solve it for 2.74?
Yeah.
Yeah. I mean, if you had this problem, y is equal to 3, no, y is equal to 2x plus 3, and they say, what's the significance of the 3? What do? You say, okay, I don't know, I'm gonna put y is equal to 3 and solve for x. Oh, look at me, and now I see x is 0. What does that mean? That's the analogous thing in a linear equation. What's the significance of 3? Well, then, obviously, you said y to 3 and solve x. I mean, come on. No, are you kidding? You don't, unless you already know that that's going to give you the answer, that's not a great logical way to start. Not thinking. Let's say you know the answer. So, yeah, you don't like this method either.
I don't like this.
What is your, I tried to explain what I thought the problem is.
Well,
you want to try to articulate it?
I use the deeper knowledge of the deeper knowledge about linear interpolation. And the deeper knowledge is that in the linear interpolation, you could always have it in terms of, the value at one value of x, plus or minus some sort of rate times times the difference between x and some point.
I don't know about you, but I wasn't following that.
Yeah.
Okay,
so,
okay.
The idea of linear interpolation, and that linear interpolation, the concept of linear interpolation, told me very quickly that 2.74 is the actual price of gas. It's not that it's a constant term. It's because not that I didn't think of it because it's a constant term. I thought of it because it is the term that appears
right. Yeah.
That appears in this form. The term plus or minus some constant times x minus another constant.
Okay, but
it's an interpolation form.
Let's jump into our explanation. Let's jump into our introductions fast.
It's flaky. The other thing that I don't like about this explanation: find x.
Solve for x. Yeah. Oh my God.
Solve for x. Don't bother. It's they should tell people. Obviously, 2.74 equals 2.74 minus something when the something is 0.
Oh, that's called a pattern.
And the something is 0 is when x equals 3.
Right, that's a pattern. Right, exactly. Yeah. But this whole
so
thing...
I should say instead of subtracting, you don't subtract both sides. No, that is the way of doing it when you don't think about anything.
Right.
Obviously, when x equals 3, x minus 3 equals 0.
Right, yeah.
Minus 19 times...
Okay, you don't forget it.
Times 0 minus 0. X is 3 minus 3 equals 0. And and so x equals 3 solves the equation.
Yeah.
Bingo, it's done.
Right.
You problem solve the equation. Find the x
Right.
that makes the equation true.
Right. Now, wait, let's go back, because you said something that's a little disturbing. So, we'll introduce us as very quickly. I'm Joel. I have a PhD in mechanical engineering. Seth, as you may have already can tell, he has a PhD in math. Seth, you're coming into this thing with a PhD in math with this fancy word called interpolation. Do you really think high school kids are going to be saying to themselves, "Oh, this is an example of interpolation"?
Well, you asked that we're doing this. We're supposed to, our rule is to react to it the way we react to it, without reading it over ahead of time, right?
Right. Yeah.
So that is honestly how I came up with it.
That's fine. Okay, that's fine.
Now, so we could imagine what a high school student would do.
Yeah, why don't you do that?
But we are not high school students anymore.
That's right.
It's hard to, maybe what we should do is get some high school student to do the video here.
That would not be a bad idea, actually. That would not be a bad idea.
Yeah.
That would not be a bad idea.
But then, I did walk through an approach that did not entail the concept of interpolation.
Yeah. No, I mean, I think the key to this problem really is the pattern. If you notice that x is 3 knocks that term out, knocks this junk or this whatever this thing, knocks this out, then you immediately get the answer. And that has to do with having some experience in observing sort of like what's going on in a linear equation. And don't forget to play around a little bit, relax a little bit, and play with it and say, what's going on here? And remember, if the problem seems really hard, stop, take a deep breath, and look for the pattern, which will almost certainly be there. And then when you see the pattern, you'll say to yourself, "Oh my God, I should have seen that like a minute and a half ago," and then you feel horrible you didn't see it sooner. But look for patterns and questions that seem incredibly difficult to do. And if you don't see that pattern, this is a toughie. So I think that's it, right?
Yeah.
Yeah, we're more than done. Okay, I'm Joel. I already introduced ourselves, and we're brothers. We try to go through an SAT question each day to to offer suggestions on how to do it. We come from different backgrounds. Seth did it one way. And he basically told me how to do it, how I would have done this. I don't know how I would have done this because Seth swooped in and gave me the clue. But we offer different approaches. We analyze the problem through different lenses, which is what you should do. It gives you more confidence and gives you more ways to look at things. And hopefully one or more of these approaches sits well with you and you understand it, and you can apply it to the problems that you will get on your practice questions and your actual tests. And in terms of practice, do as much practice as you can. The rumor is that Blue Book 4 and Blue Book 6 are the tests, at least on the math side, are the most like the actual SAT. Digital SAT, and if you want to bone up on any subject, go to Khan Academy. The College Board partners with them, and they have a digital SAT course which you can practice on a slew of topics, and they tell you exactly what the topics are. You could practice on those topics. And when you look at problems, try to look at them from different points of view. Think about what we do and how we do the problems differently, and race through the test. Get it done as quickly as possible. When you go back, take a second and look at each question and say, there was another way to do it, because maybe that other way is better on the problems you will get. Enough talking, right?
Right.
Yeah, more than enough talking. Okay, everyone. Have a great. Please dislike our videos, give us comments, and we'll see you later. Bye-bye.
Bye-bye.